Very well. Let us start chapter 4. We're going to talk about exponential and logarithmic functions. Chapter 4, 4.1, exponential function. So let us begin by defining an exponential function. Definition. Exponential function has base like b, which is a number, and it has an exponent or power, which is denoted by a variable like x. Variable. So we write y equals to b raised to x. B is not 1 and b is positive. So you have two conditions for your base. Example. So the first example is f of x or y equals to 2 to the x. And the second example is, for example, gx equals to a half raised to the x. So your base is 2, which is greater than 1, and your exponent is just variable x. For function g, your base e is equal to a half, which is between 0 and, this is less than 1, and a half is between 0 and 1. So what is our goal? Our goal is to graph these two functions and analyze their behaviors. We can use a little table, plug in some values, x, 2 to the x, x, a half to the x. Okay, let us plug in 0. If you plug in 0 here, you get 2 raised to 0. Any number raised to 0 is equal to 1. Let us plug in 1. 2 raised to 1 is equal to 2. Let us plug in minus 1. 2 raised to minus 1 is equal to a half. For this guy, you plug in 0. If you plug in 0, you get a half raised to 0, which is 1. So any number, any non-zero number raised to 0 is 1. Let's plug in 1. If you plug in 1, you get a half raised to 1, which is a half. If you plug in negative 1, you get a half raised to minus 1, which means that you have to flip your fraction. You get 2 over 1, or just 2. Okay, perfect. So let us graph these two, see what's going on. X-axis, y-axis. Let's use 2 different colors for the first function, 2 to the x. If x is 0, your y is equal to 1. So this is 1, this is -1, and this is 1. 0 and 1. 0 and 1. 1 and 2. 1 and 2. -1 and a half. So if you connect these points, it's not a line, it's a curved function. It's not linear. That's why we call it exponential function. This is just going up. So note that when base is greater than 1, the function is increasing. So this is 2 to the x. 2 to the x. Your second function, g of x, is a half to the x. And note that your base is between 0 and 1. If you plug in 0, you get 1. If you plug in 1, you get a half. So at 1, this is a half. Then you plug in -1, it is equal to 2. -1 and 2. If you connect these 3 points, this is the graph of a half to the x. And as you can see, this is a decreasing graph. Let us continue. So in general, you can say that, well, for any exponential function, like y equals to a to the x or b to the x, you can change the base, it doesn't matter. Then b is never equals to 1 and b is greater than 0. If b is greater than 1, then we have increasing function. And if b is sandwiched between 0 and 1, then you can say that you have a decreasing function. Let's define logarithmic functions. Definition of logarithmic function. So let y be equals to b to the x be an exponential function. We can define the inverse of this exponential function, the inverse of this exponential function is called a logarithmic function. Denoted by y equals to log with base b, so log with base b. He goes down here. He is attached to your log. Log with base b of variable x. There we go. Exactly. Evaluate. The first one is ln of e. So log with base e. Log with base e of e. And b. Log with base e of 1. There you go. So how do we solve this? We're going to use the definition of exponential function and simplify each of these. So the relation, the connection between these is that if you have y equals log with base b of x, then x is equal to b raised to exponent y. Y is equal to log with base b of x if and only if x can be written as b raised to 1. As you can see on the right hand side, we don't have any log function. So to simplify, we set y equals to log with base e of e. E is just mid-tier number. So it means that this is your x, this is your b, and this is your y. E raised to y is equal to e. Okay, what is y? Y is equal to what? Our goal is to simplify this. Invisible exponent is equal to 1. E is equal to e. So exponents must be equal to each other. Y is equal to 1. So log with base e of e is equal to 1. In fact, log with base b of any number which is the same as your base is always 1. Okay, let us move on to second example. What is log with base e of 1? To simplify, set y equals to log with base e of 1. Use the definition. 1, which is your x, is equal to 1 is equal to e raised to y. Okay. What is 1? What is that number? What is that value that when you raise a number like e to that exponent, the outcome is always 1. Very well. We all know that any number raised to 0 is equal to 1. So 1 is equal to 0. In fact, log with base b of 1 is always 0. It doesn't matter what your base is. As long as your x is equal to 1, the outcome is equal to 0. important properties of logarithmic functions. First of all, when you have base e in the pure number, we call it natural log. So whenever you see log with base e of x, we can write it as ln of x, and we call it natural logarithmic function. Natural log. So important properties. So far we learned that log with base b of 1 is always 0. We learned that ln of e is equal to 1. We also learned the fact that log with base b of b is also 1. If you have a log of x times y, you can write this as a log of x plus log of y. So when you have multiplication inside log, you can split that and write it with addition between these two logs. The fifth one, log of the division. If you have x divided by y, is going to be log of x minus log of y. The sixth properties is if you have log with base b of an exponential function like a to the x, then you can take this exponent, take the exponent, and write it in front of the log. This is equal to x times log with base b of . So let's go over some examples. Example. This example says, just simplify. The first one is ln of 3x. The second one is ln of 8x divided by x plus 4. The third one is ln of x to the 6th. Next one, ln of x plus 6 times ln of y. And the last one is ln of a minus ln of b minus ln of c. There we go. We have ln of 3 times x. Here you have multiplication between two values. You get x times b. If you apply the logarithmic properties, it's the log of x plus log of y. So since we defined ln to be log with base e, it's the same function. The base is e. So we can apply the same property, which says ln of 3 plus ln of x. ln of 3 is just a number. You can use your calculator to calculate this number here. For the second one, if we have log of x divided by y. This is log of x minus log of y. Suppose that x is. So here we get ln of 8x minus ln of x plus 4. Take a look at the first ln. Here you have multiplication between 8 and x. So we can simplify this more. Ln of 8 plus ln of x minus, we copy this guy down. Again, for ln of 8, you can use your calculator. It is just a number. On the exam, I want to leave them as they are. For this one, remember that log with base b of a to the x, we can take the exponent and write the exponent in front of log. We get x times log with base b of a. So the exponent here is 6. You can write the exponent in front of ln. You get 6 times ln of x. Okay, perfect. Now you have ln of x plus 6 times ln of y. First of all, you have a number in front of ln. It means that this number is the exponent of your y. You can write this as ln of x plus ln of y raised to the 6th power. Then here you have addition between two ln's. It means that the outcome is the product between these two log functions. For the last one, you have subtraction. Ln of a minus ln of b is equal to ln of a divided by b minus ln of c. You have subtraction between two ln's. It means that you get one ln with division between these two. Be careful about the order. It is a divided by b. The whole thing is divided by c, which is equal to ln of a over b c.